Hello, everyone. Welcome back to the Rev Games Academy. Today, we're diving into one of the coolest topics in game development, realistic vehicle physics. If you've ever wanted to make your car feel like it belongs in a high-speed racing game, you're in the right place. In this tutorial, we'll cover how to add acceleration to your car, implement steering, set up braking, and even include some awesome drifting mechanics. Trust me, it's going to be super fun and entertaining. So without further ado, let's jump right in. All right, before we start coding, we need a car to work with. So I've already grabbed the arcade-free racing car package from the asset store. It's totally free, and there are a ton of car models you can use. If you're interested, feel free to check it out. For today's tutorial, I'll be using the yellow car model. Now, let's drag our car into the scene. Once that's done in the package, you'll also notice there's a road prefab. Let's grab that and drop it into the scene as well. Oh, wait, it looks like the road doesn't have any material applied. No worries, let's fix that. Head over to the Assets folder, find the road material, and drag it onto the road prefab. Boom! Now it actually looks like a road. Now, if we want to make the road longer, here's a quick trick. Just adjust the scale Z value to 10 in the inspector. Oops, look at that! The road just stretched out, making it much longer. Pretty cool, right? Finally, let's position our car right in front of the camera. Just select the car, move it into place, and align it perfectly with the starting point of the track. Take a second to make sure everything's lined up nicely, and there we have it. Our scene is all set and ready for some action. Let's get this car moving. First, we need to add a rigid body to our car. As you know, the rigid body is super important for handling physics. It makes the car interact with gravity and collisions realistically. Go to the inspector, click Add Component, and choose Rigid Body. Now, let's make our car feel more realistic by adding some weight to it. Cars are heavy, right? So we'll adjust the mass in the Rigid Body component. Here you'll see the mass property. By default, it's probably set to 1. Let's bump it up to 1,000 to simulate the weight of a real car. And that's it. Now our car will feel heavier and interact with physics more realistically. Perfect for creating that authentic driving experience. Next, let's add a collider to the body of the car. This step is important if you want collision effects to work properly in your game, like when your car bumps into something or interacts with the environment. Select the body object of the car. In the inspector, click Add Component and search for Box Collider and add it. Now, it might not perfectly fit the shape of the car yet, so let's adjust the size of the collider in the inspector. Tweak it until it aligns with the car's body. And there we go. The collider is set up perfectly. This step ensures our car interacts with the physics world like a real vehicle. Let's move on to the wheels. First, we'll duplicate the meshes object in our car for each wheel. This is because we want to create separate colliders for the wheels. Once duplicated, remove the mesh render and mesh filter components from the duplicated objects. We don't need them to render anything. These are just for the colliders. Next, add wheel collider component to each of the duplicated objects. The wheel colliders are fantastic because they simulate real-world wheel behavior, like rotation, friction, and suspension. Now, you'll notice properties like radius and center in the wheel collider settings. Adjust the radius to match the size of the wheels so the collider fits perfectly. You can tweak the center to align it properly with the wheel's position, and that's it. We now have proper wheel colliders set up for all 4 wheels. All right, the setup's all done, and now it's time to bring this car to life. Let's add some acceleration. First, click on the car in the inspector. Then hit Add Component. In the search bar, type New Script. Name it Car Controller and hit Create and Add. And just like that, our script is now attached to the car. Let's open it up and dive straight into the coding magic. Let's start by declaring some variables to handle acceleration. First, I'll create a float variable named motor torque and set its value to 1,500. This variable will act as the force we apply to the car's wheels to make them rotate. Next, we'll assign the wheel collider components for all 4 wheels. This is what allows us to move the car forward and backward by simulating real-world physics. Now, let's create a function called handle movement. This function will take care of our car's movement. Inside this function, we'll capture the player's input from the up arrow and down arrow keys. Using Unity's input.getAxisVertical, we'll store this input in a variable called vertical input. This value will determine the direction of the car. If the up arrow is pressed, vertical input becomes 1. If the down arrow is pressed, vertical input becomes -1. With that input ready, we can apply the force to the rear wheels using the motor torque property of the wheel colliders. What's happening here? We're multiplying the vertical input value by the motor torque. If vertical input is 1, the full force of motor torque is applied, making the car accelerate forward. If it's -1, the force is reversed, and the car moves backward. By assigning this torque to the rear wheels, we bring our car to life, simulating real-world acceleration. And there you have it. Our car is now ready to move forward and backward based on player input. Okay, let's call the function into the update method. Time to test it out. So let's head over to Unity first, assign wheel collider references to inspector. Yes, perfect. Now let's run the game. Yes, the car is moving perfectly now, and if you take a look, you'll also notice that the wheels are rotating, all thanks to the wheel collider. Pretty cool, right? The wheels are responding in real time, simulating the movement just like a real car. Now we've got a car that not only moves, but also has those realistic wheel rotations. All right, we've nailed the acceleration, and now it's time to add left and right movement, because what's a car without steering, right? So let's jump back into Visual Studio and make it happen. First, I'm adding a new float variable called max steer angle and setting it to 30. This will define how much the wheels can turn, pretty much like how sharp the car can take a turn. Next, we'll grab the wheel mesh transform references. Why? Well, this lets us visually rotate the wheels as the car steers, making it look super realistic. Now let's create a new function called handle steering. This is where all the magic happens for turning the car left and right. Inside this function, I'll start by declaring a variable for horizontal input. This will read the left and right arrow keys. Then we calculate the steering angle by multiplying the horizontal input with our max steer angle. Finally, we'll use this steering angle to adjust the steer angle property of the wheel colliders. That's what actually turns the wheels. Now, let's make our car even cooler by ensuring the tires visually rotate and turn when the car steers left or right. For this, we'll create a new function called update tire. This function will take 2 parameters. First, wheel collider. This handles the physics of the wheel, and next, tire transform. This represents the actual tire model we see on the car. Inside the function, declare a variable to handle the tire's rotation and position. Use Unity's built-in methods to get the position and rotation of the wheel collider. This is important because the physics engine updates the wheel collider's movement. Finally, assign the rotation to the tire transform so it visually matches the movement of the wheel collider. So I will create one more new function called update tire visuals. This will help us call the update tire function for each wheel. Inside this function, I'll call update tire and pass the front left wheel and front left tire as parameters. Then I'll do the same for the front right wheel and front right tire. This makes sure both front tires visually match the physics of the wheel colliders. Next, we're adding brakes. Let's create a function called handle braking. At the top, I'll add a brake force variable and assign it a value of 3000. This will act as the stopping power for our car. Inside handle braking, I'll check if the player presses the spacebar. If they do, the car brakes by applying the brake force to the brake torque of all 4 wheels. And if the player releases the spacebar, the brakes reset by setting the brake torque to 0. Finally, we'll bring it all together. I'm calling all 3 functions: update tire visuals, handle steering, and handle braking inside the update method so everything works in real time. Now, head back to Unity, assign the wheel mesh references in the inspector, and hit play. Let's see it in action. Oh no, looks like we've got an error. Let's check the console in Unity. I see the issue. I accidentally typed horizontal with a lowercase h. No worries, let's quickly fix it. Open Visual Studio, find horizontal and change it to horizontal with a capital H. Hit save and go back to Unity. All right, now let's run the game again. Press the arrow keys, and you'll see the car turning left and right smoothly. And check this out, the wheels also rotate perfectly in the correct direction. Now let's test the brakes. Press the space bar, and the car stops just like a real vehicle. Pretty awesome, right? All right, let's move on to final state add drifting to our car. Have you ever seen those cool drifts in racing games? Well, we're about to bring that into our game. And let's open Visual Studio and write a function for drifting. First, we declare a float variable called drift factor. This controls how much the car slides when we drift. If you increase this value, the drift will be more intense. Next, we create a variable original friction to store the default friction values of the wheels. Then, inside the start function, we save the friction of the front left wheel. We'll use this later to reset the friction after drifting. Now, let's create the apply drift function. This function reduces the stiffness of the wheel's friction, making it slide more. The lower the stiffness, the more slippery the car feels when drifting. Now, let's create a function called handle drifting. This function checks if we're holding the left shift key. If we are, it applies drifting to all four wheels. And in the else condition, just reset the all four wheels sideways. Friction. All right, we're almost there. Now let's make sure our drift function runs properly. Head over to Update and call the handle drifting function. That's it. Now let's go back to Unity and hit play. Hold left shift while turning, and your car now drifts like a pro. So far in this tutorial, you've learned how to create realistic car mechanics, from acceleration, turning, braking, and now drifting. But wait, don't stop here. Go to the inspector and play around with the variables. Reduce the car's speed, increase or decrease the drift factor, tweak the values, and find what feels best. That's how you make the game truly yours. And that's it for today. If you enjoyed this tutorial, make sure to smash that like button, hit subscribe so you don't miss the next one. Drop a comment if you want more cool car mechanics. I'll see you in the next video. Happy coding.